Okay, guys, multiplying fractions. You're going to remember this from Miss HS. Y'all did it a billion times. You know it. Fourth grade. Here's the thing. When I'm multiplying fractions, I multiply straight across. Whoa, I need a pen. There we go. 7 times 4, 28. 10 times 21, 210. And I had one of them's negative, so since one's negative, the whole thing's negative. Now am I done? No. What can I do? What can I do here? We'll see.
Divide both by 2.
Okay, I could divide both by 2, and that's going to give negative 14 over 105. Okay, is there anything else? Anything else? No? I think there is. You may not see it. You may not see it. Nick? 7 goes into both of these. How many times does it go into negative 14, Kentaro? It goes into negative 2 when I cancel the 7. What about the 105, please? Henry? Not negative 15, just 15. So my answer is negative 2/15. Now the reason that I did it that way, guys, is because I want you to see, I want to look at this problem again. 7 over 10 times negative 4 over 21. You guys know that if the signs are the same, then the answer is positive. But if the signs are different, as in this case, the first one's positive, the second one's negative, then the answer is negative, right? I have one negative, so the whole thing's negative. But guys, look at this. Rather than working with those big numbers like 28 over 210, I didn't immediately see that 7. Before I multiply, what do I want to do, Julian? Before I multiply, that's right. I want to cancel any common factors on the top and on the bottom. Do you see that with the 7 and the 21, 7 goes into 7 one time, 7 goes into 21 3? That makes this problem a lot smaller. But I'm not done yet. Does anyone see anything else I can cancel? We'll see.
4 and 10.
2 goes into 4 2 times. 2 goes into 10 5 times. Now I think that's all I can cancel. Right? So now I'm going to multiply straight across the top. I've got 1 times 2 gives me 2. And 5 times 3 gives me 15. And remember, this one of our fractions was negative, so we make the whole thing negative. Negative 2 over 15. It's a lot easier working with those small numbers than it is working with the bigger numbers, because sometimes there are some factors that we may not see. Okay? Will?
For the 5 and the 10? For the 4 and the 10?
4 and the 10, yeah.
Why did you put the 5?
Because they both have a 2 as a factor, the 4 and the 10. So I cancel them out. 2 goes into 4 2 times, and 2 goes into 10 5 times. I canceled out those common factors. Guys, whenever I cancel, I have to cancel from the top and the bottom, not side to side, never side to side. Top and bottom. They don't have to be in the same fraction, but one has to be from the top and one from the bottom. Taggart.
Why does one have to be from the top and one from the bottom?
Well, you can think about it like this. This problem, when we started, Taggart, said 7 over 10 times negative 4 over 21. Okay? Now, I'm going to rewrite this. I hope this is okay with you. 7 over 10 times negative 4 over 21. Right? Do you agree that I can actually write this as a fraction right now? I can just say that this is 7 times negative 4 all over 10 times 21. Is that true? Okay. Do you agree that I can rewrite this as 7 times negative 2 times 2? Right? Because that's what the negative 4 is. All over 2 times 5 times 3 times 7. Do you agree with that? Okay. This 2 cancels with that 2. This 7 cancels with that 7. Do you see top and bottom? Right? Not side to side. Top and bottom, because one's being divided by the other. And they just turn into ones. And then when I get to the end, this is negative 2 over 15. All right? See you at example 2.